Thank you, Chagun. I once again welcome all the distinguished speakers and all the participants in the workshop on diversity of knowledge, people and practices. As we all understand that in science, technology, and innovation discourse, knowledge cannot be looked at without the social construct of its production. All knowledge originates from somewhere and it is carried by someone, and that is the reason why we have to and we need to talk about practices and people both when we are talking about diversity of knowledge. So this workshop on diversity of knowledge will take place in two segments. The first segment of the workshop will focus on diversity of knowledge, and it will provide the practitioners and academics' perspective on diversity of knowledge. The second segment of the workshop will focus on the role of people or role of the knowledge holders in diversity of knowledge discourse. Then first and second segments will be followed by the third segment, which is the most important segment, open discussion, where our participants will be engaging with our eminent speakers. They will be posing questions, making comments, and adding meaningfully to the discussion. So before we open, or before I introduce the speakers from the first segment, I would like to request all of you to note down your questions, your comments in the notepads that you have, and place it to the nearest fishbowl that we have put in. In the 20 minutes break after the two segments, we will collect all the thoughts, all the questions and comments, and that will help us drive the open discussion of this workshop. So we will start with the first segment. As I said, first segment is about diversity of knowledge from practitioners' point of view. And we have with us Professor Wiebe Bijker, Dr. Annapurna Mamadipudi, and Ozramma. So through the years of experiences and practice, they will weave the narrative of plurality of knowledge with the help of handloom as a socio-technology and many other case stories that they have captured through the years of experience. Professor Bijker will talk about plurality of knowledge. Professor Bijker is Professor Emeritus at Maastricht University of Netherlands and Norwegian University of Science and Technology. He is a trained physicist and an engineer, and he has a PhD in history and sociology of technology. His research interest lies at understanding the relationship between science, technology, and society through case studies, and he has done a significant amount of work in India with his colleagues working in different sectors of science, technology, and innovation. Professor Bijker also acted as a head of Dutch delegation for G20 Chief Science Advisors Roundtable, which was chaired by our principal scientific advisor. Then we have with us Ozramma, who will be talking about green and sustainable futures, story of handloom, with her 25+ years of experience working with cotton growing, spinning, and weaving, and advocating small-scale production chains. Ozramma is also founder of Dastakar Andhra Trust and Malka Trust, and she has also co-founded Handloom Future Trust. Joining both Professor Bijker and Ozramma, we have Dr. Annapurna Mamadipudi. Annapurna will be talking about handloom as a socio-technology. She is a scholar of science, technology, and society studies, and she's a trustee of Handloom Future Trust, which works at the intersection of knowledge and livelihood. Annapurna's research interest focuses on how craftspeople innovate and make knowledge claims to build value for their work. With this, I will hand it over to Professor Wiebe Bijker for his intervention and for his talk on diversity of knowledge from an academic and practitioner's perspective. Over to you, Professor Bijker.
Thank you very much, Chair. Thank you, Dakshata. I apologize to all of you for not being there in person, and of course missing all the networking and particularly the good food and the good coffee. But I'm very grateful to the PSA office team for arranging this online presence. I want to argue that the classical view of a hierarchy between different types of knowledge, science being on the top and other types of knowledge lower, is invalid. And more importantly, it's even counterproductive for research, innovation, and sustainability. And I will do so by proposing that the principle of epistemic justice is not just a nice ethical adagium to follow, but it's even more importantly a forceful plea for enriching our policies of science and technology. And as the chair mentioned, I will use different examples. I will start very briefly with nanotechnology, and then more elaborately, particularly by listening to Ujrama and Annapurna, we will go into handloom weaving. Of course, as this program in the afternoon very nicely shows, the diversity of science and technology is both a matter of diversity of knowledge and diversity of people. And there is a lot of overlap. I'm sure that Professor Gupta and his colleagues in the next segment will talk a lot about the content of science and the content of innovation. And in this segment, we will also talk about the people carrying and executing that knowledge and that innovation. But for analytical purposes and to shape a program, it makes a lot of sense to take them apart. So I'll focus on the diversity of knowledge in science and technology. Epistemic justice. I learned this concept from my friend and colleague Shiv Viswanathan. He was approached some 20 years ago by activists from denotified tribal groups who said, we are suffering unjustified police violence, we have health problems that seem only to happen in our groups, and we don't feel that we are listened to properly. Can you, Shiv Viswanathan, can you organize a roundtable where we can explain our experience of problems and our view of possible solutions, and at the same time, at that roundtable, listen to representatives of, for example, the police, public health authorities, and other scientists and knowledge bearers. Shiv organized something like that, and from that experience, he coined the concept of cognitive justice. And he used that to argue that different forms of knowledge have the right to coexist, like other human rights, as the global community has adopted them through the United Nations. In addition to the generally adopted human rights, we should also add, Shiv argued, cognitive justice. But then, this is not just a matter of tolerance or liberalism, but it actually invites us to embrace the value of that knowledge plurality. Now, Shiv used the term of cognitive justice. By now, the whole idea has gained a lot of acceptance worldwide, but it has changed its label. And it is now more often called epistemic justice, and I will continue to use the term epistemic justice, but still owing the basic ideas to Professor Viswanathan. And I want to particularly stress that it is not only important for democracy, for justice, for building a better society in that very wide and general sense, but it's also important to help us rethink research and innovation and to expand science and technology horizons, to come back to the title of this whole conference. Let me first give you the example of the first Indian scanning tunnel microscope, which was developed by Professor Dharmadhikari at the University of Pune in 1988, only 7 years after the very first STM was developed. You see a picture here, it's standing in a discarded refrigerator. Nothing was available at that moment at the front end of research to build such a microscope. Professor Dharmadhikari had to pick up materials from junk markets. He took apart computers. He built the whole thing in a discarded refrigerator. He used sewing machine bobbins, tire tubes. He had to, because this was so much at the front of research that nothing was available from the shelf. I use this example to argue that the classical hierarchy of science on top and other forms of knowledge at the bottom doesn't hold if you want to understand what's happening really at the front of science research, the top end of research. Professor Dharmadhikari had to make use of working around bricolage. In India, you might call it jugaad. He had to tinker, he had to pick up waste, and indeed even use indigenous knowledge. He used the indigenous knowledge of a spring maker, someone sitting having a small shop at the side of the road, a spring maker who used his particular knowledge about making springs specifically to the requirements of Professor Dharmadhikari to end up building that well-working first scanning tunnel microscope. And this is not something Indian. It's not something of the global south. This is an iconic picture of the very first transistor, which earned the scientists at Bell Labs the Nobel Prize. Well, if this isn't a combination of scrap and old materials, what is it? So my key point is that really also this STM microscope produced excellent international research with publications, almost 100 publications in international top scientific journals. Dozens of master's students and PhD graduates were trained, ending up being hired by European and United and US laboratories and universities. So there's no question that this is top science. The point I'm making is that it could only happen because of a combination of different forms of knowledge, including the knowledge of that roadside spring maker. Now, I've used this argument, this example, to basically question the hierarchy. Let's now dive into depth and try to explore what this plurality of knowledge means by going into detail into the handloom weaving example. And we will first listen to Uzarama, and she will ask the question, why handloom? Why is handloom important apart from being an example in this session? Why is it more widely important in society? And her answer is, it is a way to rethink our industries to work towards a more sustainable future. Then we will listen to Annapurna, and Annapurna will ask, why look at handloom and other crafts and other systems through the lens of STS, through the lens of science, technology, and society studies? And her answer is, that allows us to look at socio-technical ensembles rather than isolated technologies or isolated theories. And looking at those socio-technical ensembles, we are better able to recognize how knowledge is produced, how knowledge is traveling, and how innovation can be scaled. So please, can I ask the technicians to give the floor to first Uzarama and then Annapurna.
When I began working with cotton handlooms 35 years ago, I looked into archives such as the India Office Library in England and the Ames Library in the US. I found that the archives in these libraries were put away on dusty shelves, relegated to the past. But on looking into them, I saw that they carried hints for a bright future for Indian hand weaving in the 21st century. Today, we live in the shadow of global warming. where mechanized industries, including the mass production of textiles on mechanized looms, have added to the temperature of the planet. And, by the way, India is one of the top 5 of the world's mechanized textile producers. But let us consider this. India has 95% of the world's handlooms. Though many weavers have given up weaving, over 4 lakh looms are working today. Handloom weaving generates no pollution and needs no artificially generated energy. When I started working in handlooms, chemical dyeing was the most unsustainable technology in the whole process. Using archival recipes, as well as knowledge gained from the Bhishma Pitama of natural dyeing, Sri K.V. Chandramouli, we introduced natural dyeing into our handloom textile process. Taking over from him, Mohammad Salim, who was originally a car driver, made it possible for Malka to train large numbers of dyers in the technology. Sri Yellappa from Uravakonda in Andhra Pradesh, who was an expert in indigo dyeing and had taught it at the National Institute of Design, was another of our teachers. Today, Malka's natural dyeing tradition is continued by Odalu Urugunda. Natural dyeing has seen a huge increase in demand in these last 20 years. This is an instance of using past knowledge to guide future directions. In pre-colonial times, cotton farmers, spinners, and weavers met at local weekly markets. As Harry Rivet Karnak's report from 1869 shows, you can see that on the left in the slide. Of course, these relationships were broken when large-scale centralized spinning mills were introduced. One such technology was the compression of cotton fiber into bales, introduced in the 19th century to carry cotton on ships to the spinning mills of Lancashire. Baling needs expensive infrastructure. It also damages the cotton fiber as compression presses trash such as bits of stem and leaves into the fiber. Opening the bale is an even more violent process that needs more expensive machinery. I realized that this large-scale centralized spinning broke the relations between small-scale farmers and weavers who lived nearby, often in the same village. The spinning machinery invented in the West is suitable only for long staple American cotton, which farmers are forced to grow. The strain of growing these varieties, which are unsuited to Indian conditions, has been the cause of the thousands of suicides of cotton farmers over the last 20 years. Malka has eliminated the need for baling by setting up small-scale spinning technology and using cotton fresh from the field without baling it. Now, farmers can grow organic short-staple cotton, which can be handled by the Malka spinning technology. Putting small-scale spinning near farmers' fields remakes the socio-technical connections between farmers, spinners, and weavers. When they see the cloth woven from the cotton that they have grown, farmers also want to wear it. Handloom weaving, particularly of cotton, an inherently sustainable industry, can be made even more sustainable when the interrelations between the people involved are strengthened. Malka introduces cotton farmers to cotton spinners and weavers, creating a sense of democratic, mutual ownership of the means of production. By abandoning the hierarchies of the past, cotton handloom weaving becomes even more of an industry for the future. Thank you.
Hi, everybody. As you've just seen from listening to Uzrama, one of the questions that I got, because we had been working together in the NGO for a very long time, was why do we need research about handloom weaving when what people actually need is livelihoods? And that's when what I had learned from Uzrama, which is that you cannot separate the economics from the socio-technology of weaving, became very useful to actually try and understand what is happening in handloom weaving. Now, from the other side, I actually did my studies with Professor Biker in Science Technology Society Studies. And why this works is because in this discipline, there is a concept of symmetry, which basically takes all claims of knowledge on equal terms. So they don't already prioritize science over other ways of knowing. And this gives us excellent tools to understand knowledge in other ways of knowing. And what you see here is a picture of a conference in Chirala. And if you pay close attention, you will see that there are 3 disciplines in 3 different circles. On the right, you can see Uzrama working with all the NGO workers in a little circle. You see Weber with the historians of technology who came from all over the world. And you see sitting on the ground are the actual weavers themselves. And what is interesting is all 3 of them are actually debating what does it mean to innovate handloom. So one of the questions that is frequently asked of me is, how do you look at something like traditional indigo dyeing or craft knowledge and talk about it in terms of technology or technical knowledge? And one way to do it is look at the kind of concepts that come to us from technology, like standardization, like scale, like innovation, and see how you would understand those things in terms of craft knowledge. Say, for example, the indigo dyeing example. Indigo dyers can tell how blue the vat is. That's what you see on the left. It's a fermentation vat. They can see how blue the color is by smell. Now, they tell it by memory, and they communicate it to each other by song. Now, customers too, when they smell the indigo, know that it is genuine. So both of them, both the dyers and the customers, use actually smell to tell color. And in a way, what you can see is that this has a shared vocabulary with science technology studies, which talks about sensory knowledge. It talks about archive as memory, and the mode of sharing might be presentation, where we have song. But clearly, this kind of standardization of knowledge and sharing of knowledge is very similar at its base. A second question is always of scale. And the idea that we have in mass production is that you can take these processes and scale them separately. For example, you can scale the growing of cotton, you can scale the dyeing of cotton, you can scale the spinning of cotton. But the way in which it is organized in handloom weaving is that the knowledge is distributed in a way which has to be coordinated. So the number of spinners, to the amount of farming that is done of cotton, to the number of weaving, the number of dyers, these are all together, they make one socio-technical ensemble. It's a collective. And if you want to scale it, what you do is that you scale the number of these ensembles rather than in silos. And then you begin to understand exactly how scale operates without becoming unsustainable, because it's always linked to the material. Now, what happens with innovation? So to the right, you see a picture from that same conference where a weaver from Chirala is learning a very, very complicated new technique from a weaver from Laos. For this weaver, it's a way to innovate. For the other weaver, it's a way to share their knowledge. And if you think of innovation as being a creative process of learning, and you see it as always being embedded and embodied, then you begin to see the innovation in weaving and don't just see it as the same craft being produced again and again. I would like to end with another example, but this is from the side of Professor Baikar, with whom I had worked with on the problem of burning rice straw in Punjab. Now, a company had come to us and said there is an enzyme that can break down this rice straw, and would you find out if farmers would be interested in using it to produce biogas? Now, what we found interestingly is that we did not need the enzyme to solve the problem, but rather, if we started looking at it in terms of knowledge, we found that it was the organic farmers who knew how to break this down using organic processes. So the solution was not the enzyme, but a recognition of the farmers as having knowledge. Now, you could say, so how do you recognize this knowledge? And this is where professors and historians of technology like Weber become very important, because they are knowledge practitioners and they are very good at grasping that moment at which the knowledge exchange is happening. So, for example, in this large meeting, we had all the straw burning farmers and the organic farmers talking to each other, and they were quite hostile to each other, till suddenly there would be one organic farmer who spoke a solution that was very interesting. And at that point, the people from the audience would say, mobile number, asking him to share his number so that they could get back to him to get that knowledge. Much later, Weber explained to me that that was the moment, the pedagogic moment, when the recognition that it was actually a knowledge exchange was happening. Now, while I found the idea of the shout for the mobile number amusing, what Weber saw was a validation of knowledge, an explication. So he used that moment to explicate the scientific knowledge from what looked like a social process. So these are some examples that we bring to you about how you can look at knowledge and different ways of knowing when you don't disembed the knowledge from the material practice and from social arrangements. Thank you.
I would like to end this segment by asking the question, what relevance has all this that we have tried to show you for policy making? I'll try to make 2 points. The first are implications for research policy. The second one is more generally for socioeconomic policy. One implication I think this shows is that it is important to include local knowledge systems in the design and execution of all research and innovation. I'll give you one example from a joint Indian-Netherlands project. The Netherlands and India have a joint knowledge and innovation agenda called WA, Water, Agriculture and Health. And one of the projects that we together fund is Water for Change. And the aim of the Water for Change project is to develop water-sensitive cities. And a key element in that project is to go, there are 4 case studies in India, 4 cities in India, to go to the citizens in those cities and ask them about their experience with both drought and flooding. Where does it happen? When does it happen? What are the circumstances? And what do you remember of your parents, grandparents dealing with those problems? That local knowledge is then fed into the larger project, combined with high-level engineering and natural science knowledge, and that together hopefully will allow the Water for Change project to answer the scientific question, how can we make our cities more water sensitive? The second implication is more broadly for socioeconomic policy. I think that the argument, the example of Handloom shows that they do need subsidies, but they need subsidies to further innovate, to do research, rather than subsidies for welfare or to put them into a museum. It's too valuable to put handloom in a museum, I would argue. It will even allow us to rethink current socioeconomic system of vulnerability. That it's quite vulnerable, and it is draining our earth by mass production. And I want to finish with an example from a blog that Annapurna wrote during the pandemic, where she observed that at the same time that there was a shutdown of sweatshops and factories all over the world, also in India, in large cities, resulting in an exodus of workers from cities. And we have all, I mean, also in the Netherlands, we saw those dramatic pictures of long queues of people walking towards their villages and being extremely vulnerable, not only to the pandemic, not only to the coronavirus, but also to drought and starvation, etc. At the same time, craft communities continued their production. They demonstrated their resilience to combine production with livelihood and a care for people and nature. That just continued. And that was supported by a distributed system of local knowledges, and through that distributed is crucial. That's that socio-technical ensemble that I mentioned before, listening to Uzrama and Annapurna. Because of that distributed local knowledge system, they could flexibly cope with the challenges that the pandemic posed to them. To conclude, epistemic justice, and when I say that, I mean the recognition of a diversity of knowledge systems, has immediate and promising implications for science and technology policy, but it is also an invitation for developing a new vision for how to build more sustainable societies. And in that sense, I feel very happy to have made this argument within a whole day of discussing how to expand the horizons of our science and technology. Thank you.